All right, let's get started. Good morning, everybody. Welcome to a wonderful morning at Chem 1211 with your host, me, Dr. White. I hope you're ready for an exciting day or morning. Actually, you're not going to be here the whole day, but I hope not, because I should be able to get you out in time. I always do. Uh, what will we be doing today? Well, the game plan is first of all, I'm going to go through chapter 10 problem sets. Next, after that, I'm going to do some extra practice with you you'll find very helpful. And then we'll go through today's lab, which is balancing equations. Is my timing good? We just talked about it in lecture, and you'll do some practice in the lab. And with that, I'm going to get going. But before that, are there any questions? Remember, in my class, there's no such thing as a dumb question ever. Oh, one other thing. Today, at the end of the lab, I'll be doing something new. I tried it yesterday and it worked out pretty good. I'll pick five people and we'll set up a breakout room. The rest of you can go bye-bye if you want to. And those five will get to talk to Dr. White for a while. Then I'll leave and you can talk to each other. And then you can leave. And for those of you who have questions who are not in a breakout room today, after about 5-10 minutes, if you want to leave, come back or stay, I'll come back to the regular Zoom meeting part of Zoom and I'll answer your questions. So with that, let's get going. I already see a question. Oh, I already saw that. All right, just check. Thumbs up, people. Do you see chapter? Thank you. You guys are good. Thank you for helping me out. All right. You should know how to answer the following question. What ions will the following element form? And the first one is sodium. Now, how do you do that? First of all, you have to know how many electrons and protons sodium has. How do we do that? We don't use this interface. We go to our friendly neighborhood periodic table and see sodium Na has, the atomic number tells you, 11 protons and 11 electrons. Next, look for the nearest noble gas numerically based on atomic number. And neon is 1 away, argon is 7 away, which is a smaller number. And hope you all picked 1. So neon, how many electrons does neon have? 10. So let's get back. And we start with 11 electrons, 11 protons, which we got from the atomic number. And then it wants to go to have the same number of electrons as neon, 10, but you never lose protons. And then each electron is a -1 charge, and each proton is a +1. Do the math, -10 plus 11. You add it up, you get a +1. When the charge is this +1 or -1, you don't use the number to show the ion. Here's the chemical symbol. Then to the right, superscript, there's a plus sign. All right, let's do another one. Now, I'm going to have you do one. What ion does calcium form? And I'll help you out in case you can't see it. Calcium is right here. And the first thing you have to figure out numerically, what is the nearest noble gas? Give you 3 more seconds. 5. That's about 5 seconds. And you have 2 choices. Argon at 18, 2 away, and krypton at 36, which is 16 away. Which is smaller, 2 or 16? And hopefully I'll pick 2. So calcium wants to go from 20 electrons to 18. Now, you don't have to show this on a test, but I like to do it. And we said it wants to have the same number of electrons as the nearest noble gas, argon, but the protons don't change. And therefore, we have each electron is a -1 charge. Each proton is a +1 charge. Do the math. Add these together, and you get it's a +2 charge. But the question was, show the ion. And what that means is chemical symbol, and then +2, which is the old way, which I like better. Or you can also write it, which I don't like better, but would be correct on a test, 2+. And that's how you do. Oh, let's do one more. And how about let's do nitrogen? And I'll let you try that on your own totally. And in case you don't have a periodic table handy, there's one to do, use. Oh, my heart feels good seeing all you people out there working on this. Makes me happy. And for those of you who don't have your camera, well, I think you're working on it, and that makes me happy. And I'm going to try something new. Let's try a poll. Now, one of the nice things about polling is I can end it and relaunch it. And based on the polls so far, I think everybody's done. So let's do it. So if we look at here, we're doing nitrogen. Nitrogen has 7 electrons, 7 protons. How do we know? The atomic number. What's the closest noble gas? And you have neon 3 away. Here, helium is 5 away, and argon is 11. And the closest is neon at 10. So it wants to go from having 7 electrons to 10 electrons. So it starts out with 7 electrons, 7 protons. You never change the protons, but it would want to get 3 more electrons to have an octet and be happy. And therefore, let's do the math. Each electron is a -1 charge. Each proton is a +1. Can everybody see this? Okay. And then this will be +7. Add it up, you get a -3. So the actual ion, write the chemical symbol, superscript to the right. You can write -3, or the newer way, which I don't like, 3 minus. I guess it matters what you're brought up with, what you're comfortable with. Either way is correct. And that's how you do ions. And let's move on. Oh, one more thing I should point out. Once you know one member of a family, not counting hydrogen, but lithium, sodium, and potassium, what ion it forms, you know the rest. So therefore, if we know sodium forms a +1 ion, we know lithium and potassium does also. If we know calcium forms a +2, so does magnesium, nitrogen -3, so does phosphor. The halogens are all -1, and you don't form ions, at least I've never seen it, with the noble gases. So I'd never ask you that. That wouldn't be fair. And let's continue on. Now, next one is write the empirical formula, which means the simplest formula of molecules formed from the following ions. How do you do that? Well, you remember all molecules have a net zero charge, which is what I wrote down here. Remember, all molecules have a net zero charge. What does that mean? Well, let's look at the first one. If we have what ion is formed if you have Na plus and bromine minus? Well, this is a +1 charge. This is a -1 charge. That's what this tells us. And it's always true this has to add up to 0. Well, it does. So how do you know what to write? That tells you in this molecule there's 1 sodium, 1 bromine, and we do this. Now, why don't you try this one on your own? What would be the formula of a molecule formed from sodium cations and oxygen anions? And someone asked a question yesterday, which is a good question. Will I ever ask you to identify anion and cations on a test or the final? And the answer is no. And I said that when I was talking about it, if you go back and look at the video. Oh no, there's evidence of what I said in this class on YouTube. Oh no. If you're done, give me a thumbs up. How many people like the thumbs up better than the polling? Give me a thumbs up. No, nobody likes the thumbs up, I guess, for one person. We'll try both. I see one person. All right, let's do this. Question is, what's the formula of a molecule formed with sodium cations and oxygen anions? This is a +1 charge. This is a -2 charge. All molecules have a net 0 charge. Does this add up to 0? No. Well, you can't change the charge. Students like to do that, and it's always wrong. So what do? I can change how many. To get this to 0, if this is a -2, I want this to be a +2. How do I do that? I have 2 of them. And how do we show that? That tells me I need 2 sodium and 1 oxygen. Now, let's look at the following, and I'll do this one, then I'll let you have one. Now let's look at polyatomic ions. And again, what's the formula for the molecule formed with calcium +2, and this is the hydroxide -1. This is a +2, this is a -1. All molecules have a net zero charge. Does this? No. What do we do? Well, if this is a +2, I need this to be a -2. I'll put a 2 there. Well, how do we show that? I have 1 calcium. That's what this tells me. But how do I show 2 of the hydroxide? Well, when it's a polyatomic ion, there's more than 1. You have to put it in a bracket. And how many do I need? 2, subscript to the right of the bracket 2, and that's calcium hydroxide. That's a major part of cement. And you know I'm going to share the fun, so and why don't you try this one? What would be the simplest formula for a molecule with magnesium +2 and nitrate -1 ions? Dr. White's going to be real cruel today. I'm going to work you hard. Let's try to poll again. It looks like most of you are done. So let's go ahead. And how do we do this? Remember, all molecules have a net zero charge. And this is a +2. This is a -1. It has to equal 0. Oh, it doesn't. How do we get this to be a -2? We have 2 of them. You cannot change the charge. No, you can't. Why? You can't, because that's the way it is. And therefore, students try to, and it's always wrong. Don't do that. How do we show this molecule? Well, there's 1 magnesium, and there's 2 nitrates, and therefore I'm going to put it in a bracket, and I'll put that right there. Oh, let's do one more of these. These are fun. Where am I? E. And I see a question. There you go. And the answer is yes, I can scroll back. And I did. You're welcome. Aren't you glad you have an instructor who looks out to see what students' needs are and fulfills them? You're welcome, Maria. Now, I can't scroll back to the beginning of time because I wasn't recording then. Oh, that was a lame joke. Remind me, never use that again. All right, let's continue. This is the one you should be working on now. What's the, yep, it was lame, Maria. Anyways, what's the molecule that's formed with sodium cations? SO4 minus 2 is called sulfate anions, which I will never ask on a test, but I should use the name because I know it, and you'll learn it too. Well, it looks like everybody's done. I have a question for someone to answer. When I do a polling, does something pop up on your screen saying the poll question? Thank you. I just wondered because I don't see it. I just see the poll question results. All right, let's do this. How do we determine what's the simplest formula or the molecular formula of a molecule that contains sodium cations and sulfate anions? This is a +1. This is a -2. All molecules have a net zero charge. This doesn't add up to 0. How do we get this to be a +2? Put a 2 there. How do we show that? I have, this tells me 2 sodium and 1 sulfate. When you only have one polyatomic ion in a formula, you do not use brackets. And it'd be Na2SO4, and that's sodium sulfate. Ooh, time out for real world chemistry from Dr. White. Now, sodium sulfate is Na2SO4. How many of you have ever seen the little packets you get like in electronics, or even now they're putting in some food things where it says, do not eat this? And I had a student years ago who said, oh, when I was young, I ate one of those, didn't get sick. But anyways, what are those little packets? Why do they put them in? Especially for optical goods like binoculars, telescopes, or your cell phone or other electronics, because it's sodium sulfate, Na2SO4, and that absorbs water, ties it up. And one thing you don't want in electronics that's sitting on a shelf or optical goods is water vapor in there. It'll ruin it. And that's why they put those little packets in. Same thing with certain foods now. Where did I just see one? Oh yeah, when I opened a packet of what is the dried seaweed called? Nori. They had one in there. Dr. White likes seaweed, both the real stuff and the dried roasted stuff. And the answer is yes, I can. So let's go back to the whiteboard. All right, when you have more than one polyatomic ion, you need brackets. When there's only one polyatomic ion, like this case, you don't need brackets because there's only one of them. However, how would you show without brackets this? You wouldn't put N2O6. That's something totally different than NO3 in brackets. And that's how we know when to use it. When you have more than one polyatomic ion, like here or here, in a molecule, you use the brackets. When there's only one, you don't. And hopefully that helped. And by the way, thank you for your question. Remember, all questions are good questions, and I practice what I preach. All right. First of all, let me check. Did I answer that question for the person who answered it? Asked it? Good. All right, let's move on. Now, next thing is draw the Lewis structures for all the following and circle all double and triple bonds. So let's look at how we do Lewis structures of molecules. And the answer is yes. All right. Can you people keep a secret? Shh. Can you keep a secret? If I have practice problems or something, that means it's fair game to put on a test. I'll say that again in case you didn't catch it. If I have practice problems for some concept, it's fair game on my test. And therefore, if I'm practicing it with you in the practice problems, it's fair game. Uh, and if you forgot, pledge I make and I keep, every concept behind every question on every test and the final I write, I have covered it at least twice, probably more than twice in lecture, and also gone through the practice problem with them, that concept. Time for Dr. White to play with your head. Will that be on a test? Yes. All right. The question is, well, somebody has another question. Okay. Aren't you glad you have an instructor who knows what LOL means? All right. No generation gap here. Yes, there is. All right. Now, how do you draw? Before I even do this, let me put down something very important. If we were in a classroom, you'd be watching me write this on the board. And there are three types of covalent bonds. The first one is a single bond and has one pair of electrons. Second one, double bond, has two pairs of electrons. And the third one is a triple bond. Yeah, if we were in the lab right now, I'd say that has three pairs of electrons. I'd say, class, it's class participation. Everybody out loud. What's the first type of bond? Single bond. What's the second one? Double bond. What's the third one? Triple bond. And you should know that a single bond has one pair of electrons being shared. A double bond has two pair of electrons being shared, and a triple bond has three pair. Ooh, I think Dr. White's going to be subtle. I tell you, when I was an undergrad taking notes in grad school too, in the left margin of my notebook where I have spiral notebook, if I put a couple stars, I should know this. If I put IMP and an arrow, I better know this. And guess what? Oh, there are the 3 stars and IMP arrow. You should know. Single bond, 1 pair of electrons. Double bond, 2 pair of electrons. Triple bond, 3 pair of electrons. So now let's look at, oops, wrong color. Right color. How do you draw the Lewis structure for this? Well, first thing you have to know is for bromine, how many valence electrons? The Lewis structures are only dealing with valence electrons, which you should know are the outermost electrons. And how do we find the valence electrons? We look at the periodic table. And if you look at the top of the periodic table for each column, you'll see Roman numerals. Since I learned a couple of years ago, students didn't know how to read, a lot of them, Roman numerals, because they aren't teaching that in school, or at least they weren't taught. I also put the numeric value. And you look at bromine, at the top, VII is 7 in Roman numerals, and I have the number 7. So bromine has 7 valence electrons. And if I had 1 bromine, it would have 7 valence electrons. Remember, when you're doing an element, not a molecule, you never have more than 2 dots on a side, and each side should have 1 dot before you double up. Well, if I put another bromine, it would be the same thing. And this bromine says to that one, hey, I've got 1 unshared electron, valence electron. You do, let's share. So they do. And the non-bonding electrons that I'm drawing in now around each element, in this case bromine, are still there. Now, one of the things I've taught you, but I never asked you to define, is the octet rule. Except for hydrogen, whose octet is 2, each element, when it's in a molecule, should have 8 valence electrons, both its own and shared. If we look at this bromine, count the dots. Oh, I ran over 1 dot. Hold on. That's better. How many do we have? 8 octet. And if I look at the other bromine, how many dots? 8. And it has its octet. And that's why it shares. And what kind of bond is between that? 1 pair of electrons, a single bond. And since Dr. White likes to share, why don't you draw the Lewis structure for fluorine? Now, I'll switch real quick to the periodic table. How many valence electrons does fluorine have? Time's up. Here's fluorine. Look at the top. It has 7 also. So fluorine has 7 valence electrons. And therefore, have fun. Draw the Lewis structure. Now, well, I'll talk about something after you finish it. So everybody notice I'm pretty much up to date with my videos. And don't forget, whenever the Emmys are out, don't forget to nominate Dr. White for the YouTube Star of the Year. No, they don't give YouTube Emmys. And the winner is Dr. White for Chem 1211. Outstanding chemistry shows. And, all right, now I'm off my ego trip. I assume everybody's done. Let's do this. This fluorine has 7 valence electrons. This fluorine has 7 valence electrons. And this one has 1 unpaired. This one has 1 unpaired. They share, and this is how you do it. And you notice each one has an octet. Now let's look at something a little different, and let's look at an important thing that keeps us alive. I'd say that's pretty important. Oxygen. Right now, if you're breathing, and by the way, I hope you all are, any, what's the show? Walking Dead? Yeah. Anyways, oxygen keeps us alive. And draw the Lewis structure for oxygen. I'll do this. Well, what do you have to do? You have to find out how many valence electrons oxygen has. You go to your friendly periodic table. Right here, oxygen, look at the top, has 6 valence electrons. That's this number. And now we go back and we can do this problem. And we have oxygen, each one has 6 valence electrons. And if I put 1 oxygen, if I do another one, same thing. And now this oxygen says, oh, look, I have 1, 2 unpaired electrons. You have 1, 2 unpaired electrons. Let's share both of those. And they do. The non-bonding electrons are still there. And this is how you draw oxygen right here. Now, unlike elements, for Lewis structure for molecules, you can have more than 2 dots on one side. And you can have sides without any dots like you see here. Now, the next thing I'd ask you is, what kind of bond exists, covalent bond exists between the 2 oxygen atoms and oxygen O2 gas? Ooh, 2 pair electrons, what's that? 2 pair of electrons? It's a double bond. And I think somebody already helped me out. And the answer is yes, you helped me out. Thank you. So here we have a double bond. And if in the question I asked you to circle this, you would circle those 4 electrons. Now notice this oxygen has 2, 4, 6, 8 octet. This one has 2, 4, 6, 8 octet. So they're all happy. And now it's time for me. Well, wait, hold on. I think I warned you I have the fastest mouse wheel finger this side and the other side of the Mississippi River, and you saw that. All right, time for you to have some fun. Why don't you draw the Lewis structure for nitrogen gas, which you're also inhaling right now in the air? And I'll tell you, you can look it up. Nitrogen atom has 5 valence electrons. Your turn. I think everybody's done, so let's do this. How do we do this? Well, this nitrogen has 5 valence electrons, and the other nitrogen, same thing, 5 valence electrons. And this nitrogen says I have 1, 2, 3 unpaired electrons, and you have 1, 2, 3 unpaired electrons. Let's share. And they do. 1 pair, 2 pair, 3 pair. The non-bonding electrons are still there. And now we look, and each nitrogen has an octet of valence electrons, so it's happy. And I would ask you, what kind of covalent bond is between the 2 nitrogen atoms in N2 nitrogen gas? I see someone already got it correctly. And let's scroll up to the chart. You should know 3 pair of electrons being shared. That's a triple bond. Now, let's look at another thing that you should know how to do. Sodium hydroxide, very important chemical. The old name was lye. If you've ever heard of lye soap, it was made with sodium hydroxide. And this is one of the more important chemicals made and used in the United States, even the world. Now, everyone, listen carefully. All the alkali metals, all the alkaline earth metals, lithium, sodium, potassium, alkaline earth, magnesium, calcium, they are never, ever in a covalent bond. They are always in an ionic bond. Let me say that again. Sodium, lithium, potassium, magnesium, calcium, and the others too, but those are the ones, not hydrogen. That's another story. It's not really an alkali metal, but the alkali metals and the alkaline earth metals always form ionic bonds. Therefore, they always form cations. So let's look at how we draw the Lewis structure for, and the question would be, someone asked, would this be on the test? Get the hint? So I know sodium, when we're talking about Lewis structures, we're talking about valence electrons. Sodium has 1 valence electron, oxygen has 6 valence electrons, and hydrogen has 1 valence electron. Well, sodium always forms a cation, and you learned how to figure out that's Na+, and it's always Na+. Now, oxygen has 6 valence electrons. Hydrogen has 1, and it says, oh, oxygen, you have 1, I have 1, let's share. And they form a covalent single bond. So hydrogen has its 2 valence electrons, which is its special octet. That's the one exception to the octet rule. But oxygen, it only has 7. It wants 8. But wait, where did this electron go? It left, so sodium would be a cation. It went over to the oxygen, and now the oxygen has an extra electron with the hydrogen and has a negative charge, and this is the Lewis structure for sodium hydroxide. Why don't you try this one? Draw the Lewis structure for potassium hydroxide, and I'll help you out. One bad thing with all of you with your cameras off, I can't look around like I would in a classroom to see if everybody's done. Turn your camera. Those of you who do turn on your camera, thank you. Those of you whose room is a mess, well, you don't have to. When I was younger, my bedroom in my parents' home was always looked like a tornado had just hit it. My mother would always yell, "Clean your room up." And once I moved into my own apartment, guess what? I really started cleaning up my own rooms. All right, looks like everybody's done. So let's get to work. How do you draw the Lewis structure? Well, first of all, this is an alkali metal and always forms an ion that's a +1. Remember, I told you, if you know one, you know them all, and sodium forms a plus. Yeah, I'm having a bad plus drawing day. And therefore, I'll do that. Now, oxygen, 6 valence electrons. Hydrogen has 1. Oxygen has the share. Now, oxygen only has 7. Where does it get its 8? This electron, which left to form the positive charge, goes here. And now it has this octet, but it has an extra electron, oxygen, hydrogen, and that's the structure. Oh, let's try one more of these. Let's do a harder one. And why don't you do the Lewis structure for sodium cyanide, NaCN? One of these days, I'm going to have to get game show music to play during this, like The Price is Right or Jeopardy or all those shows I have watched in 20 years or more. They're still on TV, some of them. Ooh, I see everybody working hard, which is better than hardly working. All right. Hopefully everybody's done. I think so. I just ran out and was looking in the real world online. I better get back to work. Now, we're going to go a couple more minutes. We'll still take our break, but usually I take it at 9:50, but I'm going to take it today at 9:55. All right. Sodium always forms a cation. Carbon has 4 valence electrons, nitrogen 5. Carbon says to nitrogen, oh, look, you've got 3 single electrons. I've got 3 unpaired single electrons. Let's share. And they do. The non-bonding electrons on nitrogen are still there. And now nitrogen has its octet, but wait, carbon only has 7. Where does it get 8? Where does this valence electron go? It leaves, and that's how it forms a cation. It goes to carbon, and you now have the cyanide anion. And this is the structure of sodium cyanide. You have both a ionic bond between the sodium and the cyanide anion, and here you have a triple bond between the carbon and nitrogen. And I see a question. Kelly, go for it.
So I'm wondering if it's okay for carbon if the dots weren't where you placed them. What if they were on top of the carbon? Does it matter where they're
Yes, it
placed?
does. You put, when you have multiple bonds, you put them between the atoms that are sharing those electrons. So if you were to write something like this, and tell me if this is the way you were talking about. Is that what you were meaning?
No, I understand where the triple bond is, but on the other side of carbon, there's 2 dots. What if I put those 2 dots on top?
I wouldn't mark it wrong, but convention usually puts it on this side. Don't ask me why, but that's convention. If you, now I see what you're talking about. If you were to do this, and do this, I'd look at that and say, oh, that looks different, but it's correct. I'll mark it correct. I should mention, when I grade a test, I don't sit there, ooh, how many points can I take off on each question for the student? No, is it right or wrong? Let me look at, yeah, that's really right. I'll give them credit. And that's just the way I grade. Oh, did I give that away? Oops. All right, let's go back to the practice problems. And I've done this. Now, number 4, just put a big X through that. I forgot to take that off. The problem said I'm not teaching it this semester. Question 4, put a big X through that. All right, let's go to part 2. What's a covalent bond? Sharing pair of electrons. We've done these Lewis structures, so I can zoom past that. You should go back and practice them though. And what are the 3 types of covalent bonds? And I taught you single, double, triple. How many pairs of electrons are being shared? Single, 1 pair, double, 2 pair, triple, 3 pair. And finally, examples of molecules that can hydrogen bond. That's molecules that have a hydrogen on either oxygen, nitrogen, or fluorine. And the most famous one is water. And then you have ammonia, hydrogen fluoride, which is nasty, dangerous stuff. Hydrofluoric acid is also called, and alcohols like ethanol and isopropyl alcohol, which is a rubbing alcohol. And with that, I've gone through the problem set. And let's see, how am I doing? Let's take about a 4-minute break, come back at 10. I'll get you out early. I'll see you in about 4, maybe 5 minutes. Come back. All right, I'm not going to cheat you. Come back at 10:01. That's when your watch says 10:01. If you have a watch. Uh-oh, I don't. I'll see you in 5. All right, everybody, let's get back to work. Ring, 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 ring. All right. Hope you enjoyed your recess. Remember that in grade school when you used to go out and they'd take a break in the morning? Or I think we took it in the afternoon too. All right, let's get going. First of all, any questions about problem set? In that case, let's work on something that will help you out, and then we'll do the lab. And let's look at the following. And I'll do this one, then I'll let you try one on your own. And the question is, how many molecules of HBr, hydrogen bromide, are in 8.511, and yes, there's a decimal point, moles of HBr. So the first question is, what are we being asked to find? Molecules of HBr. What are we given? This number. And on test number 2, let me open it. On test number 2, and you can find this in the lecture section of Blackboard, important information, test number 2, you'll see 1 mole of an element equals Avogadro's number, 6.02 times 10 to the 23rd atoms of that element, and 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules of that compound. And with that knowledge, let's continue. The only number we have to work with is this. And what units do we want our answer to? If we could convert this to those units using some ratio right here. And the answer is molecules of HBr. And now it's time to use your good buddy, your good friend, unit analysis. Love that whistle. And how to use your good buddy, your good friend, unit analysis. Whatever units you're trying to get to, go on top of the ratio. Whatever units you're trying to get rid of, go underneath. I should have written this longer. And where do you get these two numbers? 1 mole of a compound equals Avogadro's number of molecules of that. Remember, when you have A equals B, there are 2 ratios you can always have, A over B, and this is not equal, but it's and a second ratio, B over A. And before I pick up my calculator, I'm going to say, do my units cancel out? Well, moles of HBr divided by moles of HBr, anything divided by itself equals the number 1. And therefore, these cancel out. The only units I'm left with is what I want. So now I can go to my calculator, which I now have to open. Whoa. And now I'll put in plus 8.511 times Avogadro's number, 6.02 times 10 to the 23rd. Just let me show you, 8.511 is 4 significant figures. This is 3. Avogadro's number is a calculated number. 3 significant figures, what most chemists use. I do, and you will. Therefore, our answer should have 3 significant. Oh, my goodness, look at this. So, did I do something wrong? Yep, I did. And this is the number you get. Now you got to round this off to 3 significant figures. I'll give you 3 seconds to do that. Go. Time's up. I gave you bonus time. Keep the 5, keep the 1, keep the 2. Use the 3 to round off. Is that 4 or less? Yes. I drop all that. So the answer is 5.12 times 10 to the 24th. Now write it down here because I didn't leave myself enough room. Now, if you don't write the units here on the test, I don't take all points, but I do. And this is how you do it. So it's time for Dr. White to share the fun with you. I already used 8. In case you can't see it, that's the 38. So how many moles KOH are 2.3 times 10 to the 38th molecules of KOH? And it's your turn. Have fun. Ooh, by the way, let me show you something important before you have your fun. Important information. 1 mole of an element equals Avogadro's number of atoms of that element. 1 mole of a compound equals Avogadro's number of molecules of that compound. Hint. Your turn. If you don't have a calculator, just set it up. And when you're done, give me a thumbs up. Oh, I see a lot of thumbs out there. You guys hitchhiking? Oh, that was awful. All right, I think everybody's done. Let's do this. Oh, I see a question or a comment. Oh, an answer. Let's find out that person is correct. All right, first of all, what are we being asked to find? How many moles KOH, potassium hydroxide? It's also an important chemical used in the United States on a wide basis. And what are we given? 2.3 times 10 to the 38th molecule KOH. And I see another either comment or a question. Let's go check. We'll find out what the right answer is. So how do we begin? Well, this is the only number we have, so I'm going to start with that. One thing I always do, and you should do, put the units down too. Don't just put the number down. Now, if I could use a ratio, what would the units my answer be? Well, we took the time to figure that out, and that's moles of KOH. As, whoa, where did it go? All right, moles of KOH. And now it's time to use your good buddy, your good friend, unit analysis. Whatever I'm trying to get to goes on top of the ratio, unit-wise. Whatever I'm trying to get rid of goes underneath. And let me write those in. And where do I get these numbers? 1 mole of a compound equals Avogadro's number, 6.02 times 10 to the 23rd molecules. Remember, anything equals something else, you have two possible ratios. And now I will say, let me check my units. Notice molecules of KOH divided by molecules KOH, A divided by A, anything divided by itself cancel out because it becomes number one. This is canceled out. Am I having the right units? And the answer is yes, that's moles of KOH, even though it looks ugly. So I better fix it up here. Or I shouldn't say ugly, unreadable. Now it's better. And now I can go to my calculator and do that. Now, let me remind you, when you're doing multiplication division, you get the same number of significant figures as the number you're multiplying or dividing that has the fewest significant figures. This has 2, this has 3. 1 is an exact number, doesn't play a role in significant figures. Therefore, my answer should have 2 because 2 is less than 3. There's my first number, Avogadro's number, hit enter, and this is the number I get. And you should round that off to 2 significant figures. I'll let you have a couple seconds to do that. And the answer is the 2 significant figures, keep the 3, keep the 8, look at 2 to round off, that's 4 or less, drop that and everything else. So the answer is 3.8 times 10 to the 14th. And there's our answer, and that's how you do it. Any questions on that? All right, let's move on to the next area that you should be familiar with. And I'll do one, then I'll let you do one. And yes, more work, more points. All right, how many grams, and G means grams, of water are 4.82 moles of water? So what are we trying to find? Grams of water. What are we given? 4.82 moles of water. This is the only thing I have to start with. I'll use unit analysis. Here's what I start with. If I had some ratio, what units do I want my answer? Well, we took the time to figure that out, and that's grams of water. And now we use our good buddy, our good friend. Remember, I promised I'd be going for the Guinness Book of World Record, saying that phrase the most times in one semester. And I'm on track, I think. Whatever you're trying to get to goes on top. Whatever units you're trying to get rid of go underneath. And where do I get these numbers? Well, you go back and look at important information, test number 2, which you'll be given. In the past, I used to make students memorize this, but as I've told you, I've changed my philosophy. I'm not grading on your memory. I'm grading on, have you learned how to use these things? And 1 mole of an element equals the atomic weight of the element in grams. And more importantly, since we're dealing with water, which is a compound, 1 mole of a compound equals the molecular weight of a compound in grams. And the molecular weight, MW, of a compound is the sum of all atomic weights of that compound. So now we have to go back here and find out what's the molecular weight, because 1 mole, and in here we put the molecular weight of water. Well, you got to figure that out because I didn't give it to you. See how mean I can be? So what's the molecular weight of water? Well, it's the sum of all atomic weights, 2 hydrogen, 1 oxygen. On test number 2, underneath your name, it will say, please use proper significant figures for all calculated or all answers, calculated answers. And under that, it will now also say, please use all atomic weights to 3 significant figures. So I have 2 hydrogens. How do we get the atomic weight for an element? You go to your friendly neighborhood, not Spider-Man, but periodic table. That's the first and last time I'll use that joke, maybe. But anyways, what's the atomic weight of hydrogen to, hold on, let me do something here, to 3 significant figures, 1.01. you round 1.008 to 3 significant figures. For oxygen, 15.999 to 3 significant figures is 16.0. And therefore, each hydrogen is 1.01. Each oxygen is 16.0. And something I haven't done in a while, but I should right now, just to be safe. Thumbs up, people. Can you see the whiteboard? Thank you. And now we multiply 2 times this as 2.02. 1 times 16.0 is this. We add them up, 18.02. Remember, when you do addition, you get the same number of significant figures to the right of the decimal as the number you're adding that has the fewest significant figures to the right of the decimal. This has 2, this has 1, which is a smaller number. Hopefully all picked 1. Keep the 0, use the 2 to round off. And the correct answer for what's the molecular weight of water is 18.0. I'll put that in here. And remember, 1 mole of a compound equals its molecular weight in grams. And now I'll check my units. Notice moles divided by moles equal 1, cancel out. I'm left with grams. And now it's time to go to my, well, wait, actually, before I do that, well, you can wait and come back, but I'll do it now. If we look here, 3 significant figures, 3, the 1 is exact, my number. My answer should have 3 significant figures. And if you round that off to 3 significant figures, keep the 8, keep the 6, keep the 7. Use the 6 to round off. That's 5 or higher. I'm going to drop that and the rest of the zeros. Increase this by 1. The 7 becomes an 8. So that's 8.67 times 10 to the 1. Okay. Hold on one sec. It should be 86.8 times 10 to the 1. That's when you round that off to 3 significant figures. I just said it wrong. I wrote it down. I was going to write it down correctly. Sometimes Dr. White's brain multitasks too many places. Now, you could write it this way. When I get too close to the you can write it this way, or I would have also accepted if you wrote it this way. And both of these would be acceptable answers for this problem. Let me make this a little smaller, and that should solve my problem. And that's how you do it. And now it's time for you to try one. And the question is, how many moles are 4.72 times 10 to the third grams of water? And up here, I've already calculated molecular weight of water, which you'll need, so you don't have to do it yourself. Am I nice or am I nice? And like I said, it's your turn. Oh, somebody likes my humor out there. Thank you. Yes, I'm a Spider-Man fan, but actually I like Thor better. I always wanted to be Thor, the god of thunder, with my hammer when I was young. Which Thor movie? There are a couple out. Actually, something that I really liked that's not really Thor, but the first couple seasons I got addicted to, and then they weren't as good. They were still quite good. Are the Vikings on the History Channel? I actually have the Blu-rays for the first four seasons with Ragnar Lothbrok. Ah, great, great show. And when you're done, give me a thumbs up. Oh, wait, I have used it. Let's try the poll again. And the votes are coming in. Will it be? Are we done? And the answer is yes. Let's do it. All right. First thing, read the problem and find out what are you being asked to find. And the answer is moles. And even though I don't have water here, it's obvious from that it's moles of water. But on a test, I should make sure I put that there. What are you given? 4.72 times 10 to the third grams of water. And it's time to use your good buddy, your good friend, unit analysis. It has been mine for many decades. Ooh, I shouldn't have said that. Here's what I have to start with. What units am I trying to get to? Well, we took the time to figure that out, moles of water. And now I'll use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to, the units go on top. Whatever I'm trying to get rid of, they go underneath this ratio. And this is moles of water, and this is gram of water. And where do I get these numbers? 1 mole of a compound equals its molecular weight. And we did this earlier. Water is 18.0 grams. And that's how we do it. Well, let's find out if we did it right. Do our units cancel out? We have grams of water divided by grams of water, and anything divided by itself equals 1. So they cancel out, and I'm left with the right units. So now it's time for me to go to my calculator. And notice both numbers are 3 significant figures. I'm in my rut again. And round that. Wow, look at all those 2s. And how do you round this off to 3 significant figures? Keep 2, keep the 6, keep 2, use next to to round off. 4 or less, drop this. So that would be 2.62 times 10 squared. So the answer would be 2.62 times 10 squared. And that's how you do it. And I thought that would be useful stuff for us to review again. Hint, it'll help you for test 2 and the final, and also test 3 to know how to do that. It's a lot of important stuff to learn, which is why we've practiced it a lot. All right, it's lab time. And today's lab, we're not going to go into Labster. It's just going to be a worksheet you'll hand in next Thursday. Don't forget the lab we did last week is due today. Make sure you get it uploaded to Blackboard. And let's talk about balanced chemical equations. Thumbs up, people. You see balanced chemical equation on your screen? Thank you. All right. Today's lab, and this is available on Blackboard for you to download. You'll balance the following chemical equations, and there's also one question you have to answer. And here are the chemical equations. Let me point out here, this is an I, by the way. It's hard to tell, but that's an I. And we're talking about this one. What's the sum of the coefficients in the balanced form of equation in problem? Hold on, there's something in my eye besides my eyeball. I hate when you get an eyelash in there. But anyways, remember the coefficients are number in front. If there's no number in front after you balance it, that's the number 1. All right, let's talk about balancing chemical equations. Remember, when you're balancing a chemical equation, you should have the same number and the same type of each type of element on each side. But before we do that, quick review. This is a chemical equation. A plus B makes C, and A and B are reactants. And C is a product. And you could have more than one too. It could be products. Same thing here, you could only have one reactant, but we have 2 here. And a lot of times I'll also call reactants starting materials. So when we have a chemical equation, we check to see, and let's do one. If you notice here, we have 8 sulfur, and we don't have 8 sulfur. So this is not balanced. So how do you do that? Well, you can't change this number, but you can change the coefficient to number in front. And here, if I have 8 sulfur, I can put an 8 there, and now I have. Students like to put an 8 there, and that's wrong, because that implies a different molecule. Now, I have 8 sulfur. How many fluorine do I have? 8 times 6 is 48. Here I have 2. How do I get that to 48? I can't change that number, but I can put 24. And 2 times 24 is 48 fluorine. And now Dr. White likes to do is check 8 fluorine, 8, this should be sulfur, 8 sulfur, 48 fluorine, and I'm done. And that's how you balance it. Now, one thing I should point out, let's do another one quick. To balance this, put a 2 there, put a 2 there, 4 hydrogen, 2 oxygen, 4 hydrogen, 2 oxygen, and 4 hydrogen, 2 oxygen. It's balanced. Now, I could have also written and technically this would balance out, but the chemical convention is you always use the lowest multiples of the coefficient. So if you can divide all the coefficients by one number and still get a whole number, you should. This would be the wrong answer on a test or in chemistry in general, and this would be the correct one. Why? Are there 2 or 1 R's incorrect? I think there's 1, but I was always first one down in spelling bee. This one, I can divide each one of these by the number 4. I get 2, 1, and 2, and that's why it's correct. All right, and that's important to remember. That's a common mistake students make. And now I'm going to let you try one. Why don't you balance this? All right, looks like some of you are having problems. Let me show you how to do this. And then you practice more in the lab. Now, you start looking at elements. Zinc 1 zinc, 1 zinc. Well, that's good. 1 chlorine. Uh-oh, 2 chlorine. It's got to be the same. So how do I get this to 2 chlorine? You don't put a number there, that's wrong, but you can change the coefficient to number in front, so I'll put it 2. Well, now I have 2 chlorine. Now this side has 2 times 1, 2 hydrogen. Oh, look, 2 hydrogen. And now I think I'm done, but I'm going to check. I have 1 zinc, 1 zinc, 2 chlorine, 2 chlorine, 2 hydrogen, 2 hydrogen, and I'm done. And that's why I'm doing the practice for the lab. I'm pushing you to do this. Why? Because on test 2, I'll have 12 points on balancing chemical equations. I always do. And on my final, I always have at least 12 points. So it's an important part of chemistry, which is why I'm putting so many problems on test 2 and the final. Now, important thing that I'd like to cover is the following. Who's ever asking a question, I'll be with you in a second. Let me just finish writing this down. It's always good to make sure I didn't copy this wrong. And before I continue on, I see there's a question. All right, if we look at this right here, the question was, why not 2 zinc? Because this side had 1 zinc, this side had 1 zinc without changing the coefficient, so I don't have to do that. If I had 2, then this would be 4, this would be 2, this would be 2, and I could divide that all by the number 2, and remember, you get the lowest coefficient, and that's why. All right, let's move on. If you have a question, you can see me after a lab today or during my office hours. Now, important advice from Dr. White, so important, I'm going to stop share. When you're balancing chemical equations, leave oxygen and hydrogen last. I'll say this again. When you're balancing chemical, you're welcome. When you're balancing chemical equations, leave hydrogen, oxygen last. You don't have to, but it makes your life so much easier and helps you get the right answer, which is all good things in my book. And that's advice I follow myself. So let's look at the example I just gave you. And I'm going to say, oh, look, there's 1 iron. There's 1 iron here. Going this way, because I'm lazy, I have 3 chlorine. Oh, wait, I only have 1 chlorine here. How do I make it 3? I can't change this number, but I can change the coefficient. So now I have 3 chlorine. Now on this side, I have 1 nitrogen. Here I have 1 times 3, 3 nitrogen. How do I get 3 nitrogen here? I put a 3 there. So I have 3 nitrogen. Now I've done everything but oxygen and hydrogen. So I'll do going this way because I'm lazy. And I'll just say, oh, I've got 3 times 4, 12 hydrogen plus 3 times 1, 3 hydrogen equals 15 hydrogen. On this side, I have 1 times 3, 3 hydrogen plus 3 times 4, 12 hydrogen. Ooh, that adds up to 15 hydrogen. And I think I'm done. So how do I proceed? I check. 1 iron, 1 iron. 3 chlorine, 3 chlorine. Ooh, 3 nitrogen, 3 nitrogen. And I forgot one thing. 15 oxygen, 15 oxygen. What did I forget? Hydrogen, 3 times 1, 3 oxygen, 3 times 1, 3 oxygen. I'm balanced. I'm done. Yay. And I'm going to ask some of you to, about 5 of you, to go to breakout room. The rest of you can go run away. And I'll say Gegensoon, goodbye. I'll see you on Monday. If you have any questions, stick around. I'm going to